Hi everyone, welcome back. Now before I start, let me extend my sincere apologies for such a long gap between the previous video and the current one, but I promise that I'll try and be a little more better. Now in this session, what we are going to do is we are going to kick off our discussion on duration, volatility and convexity. Now these are three very important concepts in fixed income: duration, volatility and convexity. Now what duration and volatility try and measure is they try to estimate the percentage change in bond price. They try and estimate how much the bond price would change for a 1% change in YTM. Duration and volatility, they estimate the percentage change in bond price for 1% change in YTM, which means if the YTM increases by 1%, how much will the bond price change by is what is measured by duration and volatility. Now, but am I directly going to give you the formula for duration, volatility, and convexity? The answer is no. What I want to try and do is, in this session, I will talk about some preliminary math concepts which you would have learned in 11th and 12th, which will help you to enhance your understanding on duration, volatility, and convexity. Okay, so I'm not going to directly give you the formula for duration, volatility, and convexity. Rather, I will be teaching some basic math concepts, something that you actually already know. I will be revisiting them so that we are able to enhance our understanding on all the three of them. Okay, now, if you actually remember in 11th class, you would have learned that the equation of a straight line is in the form of y equal to mx plus c. The equation of any straight line is going to be in the form of y equal to mx plus c, where y is called as the dependent variable, x is called as the independent variable. Now, the reason y is being called as the dependent variable is because the value of y is dependent on the value of x. The value of y is dependent on the value of x. And that is the reason y is being called as a dependent variable and x is being called as an independent variable, because the value of x is going to be random. The value of x is going to be random and hence it's going to be called as independent variable. Now, if we actually take an equation, let's say y equal to 3x plus 10. Let's say I'm taking an equation y equal to 3x plus 10. Here y is called as the dependent variable because as and when x value keeps changing, the value of y will keep changing. Therefore, y is called as the dependent variable, x is called as the independent variable. Now, m over here refers to slope of the line. M refers to slope of the line. I'll come to what the meaning of slope is. And C refers to intercept. The word C refers to intercept. Now, if we actually compare y equal to 3x plus 10 and y equal to mx plus c, obviously we're able to identify that m is equal to 3 and c is equal to 10. M is equal to 3 and c is equal to 10. Now, let's understand the meaning of intercept first. Let's understand the meaning of intercept. Now, there are two ways I can communicate the meaning of intercept. Number one is intercept is the point where the line is actually cutting the y-axis. Intercept is that point where the line is actually cutting the y-axis. For instance, if we actually draw a graph, if this is the graph that we're drawing, y equal to 3x plus 10 would be something like this. Y equal to 3x plus 10 will be something like this. This is the x-axis and this is the y-axis. This point is going to be 10. This point is going to be 10 and this is nothing but the intercept. It is that point where the line, this is the line y equal to 3x plus 10. So intercept is that point where the line is actually cutting the y-axis. That's the first meaning of intercept. Or the second meaning of intercept is nothing but the value of y when x is equal to 0. The value of y when x is equal to 0. For instance, if you actually substitute in this equation as x is equal to 0, the answer will be y is equal to 10. All right. And that is what we've actually done on the graph, because this point is going to be 0. This point is going to be 1. This will be 2. This will be 3 and so on. And this is nothing but the value of y when x is equal to 0. Obviously, both the meanings imply the same thing. The first meaning, what I said was, it is the point where the line is actually cutting the y-axis, and that point is nothing but the value of y when x is equal to 0. So in this equation, if you substitute x is equal to 0, you will get a value of y, and that is nothing but the intercept. Okay, so there are two meanings of intercept. One is it is the point where the line is actually cutting the y-axis, or the second way to understand is it is the value of y when x is equal to 0. The value of y when x is equal to 0, and that's clearly represented on the graph, because when x is equal to 0, we still have some value of y, and that is nothing but the intercept value. Okay. Now this is almost the end of discussion on intercept. After this, everything that we discuss is going to be around slope. It's going to be around slope. Now, the meaning of slope or meaning of m is nothing but when x changes by 1 unit, how much does the value of y change by? When x changes by 1 unit, how much does the value of y change by? And that is given by slope. For instance, what I'm trying to say is, let us say if x is equal to 1000, if x is equal to 1000, then the value of y is going to be 3 into 1000 plus 10, which is nothing but 3010. Right? Now, if x is now 1001, what I've done is I've increased the value of x by 1 unit. I've increased the value of x by 1 unit. Okay, x has increased by 1 unit. Now, if I find out the value of y is going to be 3 into 1001 plus 10, and this is going to be 3003 plus 10, which is equal to 3013. Okay, so now if x has increased by 1 unit, if you notice, y is increasing by 3 units. If x has increased by 1 unit, y is increasing by 3 units. Now that is nothing but the m. That is nothing but what we got as m over here, or the slope of the line. The slope of the line explains how much does y change by when x changes by 1 unit. How much does y change by when x changes by 1 unit? Over here, when x increased by 1 unit, y has increased by 3 units. Similarly, when x decreases by 1 unit, y will decrease by 3 units. Now, the reason they have direct relationship is because the coefficient of 3 over here is actually plus. The coefficient of 3 is actually plus over here. All right. And that is the reason x and y are moving in the same direction. When x is increasing, y is also increasing. When x is decreasing, y is also decreasing. Okay, so the meaning of m, or meaning of slope of the line, is nothing but when x changes by 1 unit, how much does the value of y actually change by? Okay, and that is nothing but the coefficient of x. M, or slope, is nothing but the coefficient of x. Okay, so that is nothing but the slope of the line. All right. Now, if we by chance had an equation y equal to minus 5x plus 100, then over here, m is actually equal to minus 5. And the meaning of minus 5 is if x increases by 1 unit, the value of y will decrease by 5 units. If x increases by 1 unit, the value of y will decrease by 5 units, which means x and y have an inverse relationship. They do not have a direct relationship. So when x decreases, value of y will increase. When x increases, the value of y will decrease. Okay, that is the meaning of a negative coefficient. Therefore, if m is negative, it means that x and y have an inverse relationship. If m is positive, if the coefficient of m is positive, then x and y have the same relationship. They have a direct relationship. They move in the same direction. All right. So now this is one way of calculating the slope of the line. Okay, the way that we saw is we just look at the coefficient of x, and whatever is the coefficient of x, we actually take that to be the slope of the line. That is just one method. There is a second alternative also, and that second alternative is nothing but doing the first differentiation. Now, when I say differentiation, what I'm talking about is d by dx. This is something that maybe a lot of you might have learned in 11th or 12th. What we are doing is d by dx, or doing a derivation, or doing differentiation. Okay, what we are going to do is, now we had the original equation we had was y equal to 3x plus 10. Now I am differentiating this equation with respect to the independent variable. I am differentiating this equation with respect to the independent variable, and independent variable in our case was x. Okay, I'm not differentiating it with respect to dependent variable, I'm differentiating it with respect to independent variable. Now, don't worry, I'm not going to teach you complex derivation, differentiation. It's going to be a very simple one. So when I do d by dx of this whole equation, what I get on the LHS is dy by dx is equal to d by dx of 3x plus d by dx of 10. I have d by dx of 3x plus d by dx of 10. And d by dx of 3x is nothing but 3. And d by dx of a constant is going to be equal to 0. Okay, dy by dx is equal to 3 plus 0, which is equal to 3. Therefore, dy by dx is actually nothing but 3. And therefore, what I'm trying to say is, when you do the first differentiation, this 3 is nothing but equal to m, right? This 3 is nothing but equal to m. What I'm now trying to convey is dy by dx, or first differentiation. This is the first differentiation of the equation, is going to be equal to slope of the line. Okay, whenever we do a first differentiation, that first differentiation result is going to be equal to slope of the line. And don't forget the meaning of slope. Slope refers to when x changes by 1 unit, how much does the value of y change by? Okay, therefore, if I want to find the slope of the line, not using the first method where I saw the coefficient of x, there is an alternative where I can actually do the first differentiation, and the answer of first differentiation is actually going to be equal to m. The answer of first differentiation is going to be equal to m. Okay. So this is the second way of actually finding out the slope of the line. Now, obviously, you might get a question that if I can find out the slope of the line straight away by looking at the coefficient of x, why the hell would I actually get into complicated mathematics of doing dy by dx to find the slope of the line? Obviously, that's a genuine question. We are going to see situations where we can only use dy by dx. We are going to see situations where we can only use this formula and we cannot see the coefficient of x directly. Okay. Now, before moving ahead, I would also like to make one point, that slope of the line measures nothing but the steepness or the flatness of the line. The slope of the line actually measures how steep or how flat a line is. For instance, if you look at this line is absolutely flat. This line is going to have a slope of m equal to 0. Reason being, if you remember, any line which is parallel to x-axis is going to be in the form of y equal to c. Any line which is parallel to x-axis is going to have an equation of y equal to c, which means nothing but the coefficient of x is actually 0. The coefficient of x is actually 0, which means the slope of the line is 0, which means even if x keeps increasing from 1, 2, 3, 4, etc., the value of y is actually constant. The value of, sorry, I meant to write c over here. The value of y is actually constant, which means when x keeps changing by 1 unit, the value of y does not change at all, which means the slope of the line is actually 0. Okay, so for a flat line, slope is always going to be 0. But for a line like we saw over here, which has some steepness, that is going to have a positive slope. That's going to have a positive slope. And if there is a downward sloping line, let's say I draw a line like this, that is going to have a negative slope. That's going to have a negative slope. Okay. But anyways, that's not what I wanted to discuss. What I wanted to discuss was a flat line is going to have a slope which is equal to 0. And as the steepness keeps increasing, then the slope tends towards positive 1 if it is upward sloping, and it tends towards -1 when it is downward sloping. Of course, slope is not going to be restricted between -1 and +1. Slope can have any value. For instance, over here we had a slope value of equal to 3. We also saw a case where the slope value was equal to -5. All I'm just trying to say is, if there is a 45-degree line which is passing through the origin, if there is a 45-degree line which is exactly passing through the origin, then this is going to have a slope equal to 1. This is going to have a slope equal to 1, and it has a positive slope of 1 because it's upward sloping. Had it been downward sloping like this, it would have a slope equal to -1, provided the angle is actually 45 degrees. Okay, this is not really relevant for you to understand duration and convexity, but I just wanted to make you guys understand that slope is going to also is a representative of how steep or how flat is a line. How steep or how flat is a line. A flat line will have a slope equal to 0. A steep line can have a slope of any number. It's not going to be restricted with 1. It can have a slope of any number, but a 45-degree line which is passing through the origin will always have a slope equal to 1. All right. So this is what I actually wanted to convey. Now, the last thing that I want to talk about in slope of a line is, please note that the slope of a line is actually constant. Okay, the slope of the line is constant. Dy by dx is equal to a whole number which is equal to 3, and that is going to be constant. Now, what do we mean by slope of a line being constant? It means, let us say if x is equal to 1 and x is equal to 100. Okay, now if I increase the value of x from 1 to 2 or from 100 to 101, if I increase the value of x from 1 to 2 or from 100 to 101, the value of y will still increase by 3 units in both the cases. The value of y will still increase by 3 units in both the cases, which means that it does not depend from where I'm increasing 1 unit. Like I said, the definition of slope is if x increases by 1 unit, how much will y change by? That is the meaning of slope. Okay, now that slope is going to be independent of the value of x. The slope is not going to be dependent on the value of x, which means whether I increase 1 unit from x is equal to 1 or whether I increase 1 unit from 100, the value of y is always going to change by 3 units. Okay, it is not being dependent on where we are standing right now, whether we are standing at x is equal to 1 or whether we are standing at x is equal to 100. Okay, that is the meaning of dy by dx being a constant of equal to 3. Okay, you will probably understand a little more on what I'm trying to say a little later on, where I take an example of a curve. But for now, just understand that dy by dx is actually a constant which is equal to 3, which means the slope is the same at all the points on the line. Okay, when I say all the points on the line, what I'm trying to say is at x is equal to 1, also the slope is equal to 3. At x is equal to 100, also the slope is actually equal to 3. The last thought I would like to leave you guys with is, which we are not really going to apply over here. Slope can also be calculated as y2 minus y1 divided by x2 minus x1. Slope can also be calculated as y2 minus y1 divided by x2 minus y1, where x1 y1 and x2 y2 are 2 points on the line. Where x1 y1 and x2 y2 are 2 points on the line, you can also calculate the slope as y2 minus y1 divided by x2 minus x1. Now over here, if you actually see, this is actually x1, and we got a y1 answer of 3010, and this is nothing but x2, and we got a y2 answer of 3013. If you do y2 minus y1 divided by x2 minus x1, you will get the value of slope. Okay, you will get the value of slope. Now, if you obviously observe this formula, what it is doing is it is capturing the change in y in the numerator. It's capturing the change in y in the numerator, and it's capturing the change in x in the denominator. Okay, it's capturing the change in x in the denominator and change in y in the numerator. And what we are trying to do is change in y upon change in x. Change in y upon change in x, which is nothing but how much value does y change by for a given change in x. How much does a value of y change by for a given change in x, which is nothing but the formula for slope. Okay, the meaning of slope is nothing but it's converting the meaning of slope into a proper formula where we are calculating change in y in the numerator upon change in x in the denominator. Okay, now we are done with discussing the slope of a line. We're done with discussing the slope of a line. We are now going to move on to discuss the slope of a curve. We are now going to discuss the slope of the curve. Now, a curve is never going to have an equation of y equal to mx plus c. A curve will never have an equation of y equal to mx plus c, because in y equal to mx plus c, the degree of y and degree of x is actually 1. The degree of y and degree of x is actually 1. Okay, and a curve is going to have a degree other than 1. A curve is going to have a degree other than 1. And the example that I am going to take is y equal to x square. I am going to talk about the equation y is equal to x square, a simple equation where y being the dependent variable is x square is equal to x square, which means x into x. Okay, y is equal to x into x, where x is the independent variable. Now, firstly, maybe your question will be, how do you know that this is a curve? Okay, so for that, what I've done is I have plotted various values of x from 1 to 15. I've plotted various values of x from 1 to 15, and I've taken the value of y as x into x. That's the formula that I've applied. Okay, so 3 square equal to 9, 7 square equal to 49, 10 square equal to 100, and so on. 15 square is equal to 225. So I've just plotted value of x and the value of y, and this is the graph. If you see, when x is increasing from 0 to 16, the value of y is increasing from 0 to 225. Okay, so on the y-axis we have, this is the y-axis, guys. Let me just plot it maybe. This is the y-axis and this is the x-axis. All right, so when the value of x is increasing, the value of y is also increasing. And if you see, this is actually not a straight line. This is actually not a straight line. It is a curve. If I join the dots, obviously, this is not a straight line. Over here, you might think that it is looking like a straight line, but if you see the whole thing, it's actually not a straight line because there is obviously a bend over here. It's going like this. Agree? So it's not a straight line. I'm erasing it because I want the plots to be seen. Okay. So it is actually a curve. All right. Now, any equation for that matter, which is not in the form of y equal to mx plus c, let's say if you have y equal to x cube, this is also going to be equal to a curve. Okay. If you take y, apologies, give me a second. If you take y equal to x power minus 2, this is also going to be a curve. This is nothing but 1 by x square, right? What we're trying to do is 1 by x square. That's also going to be equal to that's also going to be in the shape of a curve. Okay. Now, so the equation that we have picked up is y equal to x square. Now, obviously over here, you do not have the equation in form of y equal to mx plus c, where you can straight away see the coefficient of x to identify the slope. What we actually did in this equation was we saw the coefficient of x and we said that the coefficient of x is going to be equal to slope of the line. But over here, we do not have an x term at all. So obviously there is no coefficient of x, and this equation itself is not in the form of y equal to mx plus c. So we cannot apply the above formula that we were using as coefficient of x is equal to slope of line. We wouldn't be able to apply that formula. Now over here, differentiation is going to come to our help. Differentiation is going to come to our help. Okay. Now if you do dy by dx of this, dy by dx of x square, if by chance anybody remembers, d by dx of x power n is going to be n into x power n minus 1. D by dx of x power n is n into x power n minus 1. So here it's going to be 2 into x power 2 minus 1, which is equal to 2x. Okay, it's going to be dy by dx is going to be equal to 2x. And if you notice, 2x is not a constant. It is not a constant. In the first equation where we had a line, I said dy by dx is equal to 3, which means dy by dx is actually a constant and it's going to be the same always. Whereas over here, dy by dx is equal to 2x, which means over here, the value of slope, the slope is equal to dy by dx is equal to 2x, where the slope is actually dependent on x. The slope itself is dependent on the value of x. I'll come to what that actually means. But before that, let's try and understand over here, for instance, I said that, the slope over here is referring to the steepness or flatness as well. The slope over here is referring to steepness or flatness of the line. Okay, now if we actually come to this graph, okay, let me otherwise just take a minute off. I would like to extend the graph a little more. I'll just extend the graph up to 30 so that it's a little easier to appreciate. Give me a second, guys. I've actually changed the numbers a little bit. What I've done is I've left a gap of 5 in between. I've left a gap of 5 in between from x is equal to 1 up to x is equal to 91. I don't know why I stopped just with 91. There's no rocket sign behind it. I just randomly stopped. And the value of y is equal to x square. The value of y is actually equal to x square. All right. Now, so apologies. Let me just, yeah. Now, when we are actually trying to calculate the slope of the curve, when we are trying to calculate the slope of the curve, the first question is what is asked is, what is the value of x right now? What is the value of x right now? Are we calculating the slope with x is equal to 0, or are we calculating the slope with x is equal to 20, or are we calculating the slope with x is equal to 40, or what? Where are we actually standing? What is the value of x? Where are we standing right now? Okay, now let's say I'm standing at x is equal to 40. I'm standing at x is equal to 40, and I would like to understand what is the change in y for a given change in x. Okay, what is the change in y for a given change in x? Okay, now since I'm standing at 40, what we are actually doing is we are going to draw a tangent at this point. We are going to draw a tangent at this point. Okay, because it is a curve, we obviously have a tangent which is actually cutting this, which is actually touching this point. Okay, it doesn't touch the other points, it only touches one point on the curve. Obviously that's not very visible from here, but that is how it's supposed to be. You know, if I actually draw a curve, let's say if you have a curve something like this, then we are drawing a tangent which is touching exactly this point. Okay, we're drawing it. I know it did not touch over here, but basically we're drawing a tangent such that it touches only one point at x is equal to 40. Okay, now after drawing the tangent, we are going to find the slope of this line. We are going to find the slope of this line. Okay, so we are not actually finding out the slope of the curve. What we are doing is we are drawing a tangent such that it touches the point where we are right now standing. It touches the point where we are right now standing, and the tangent is obviously going to be a straight line, and we are going to find the slope of that straight line. We're going to find out the slope of straight line. This is going to be in the form of y equal to mx plus c, obviously. And then we are finding out the slope of this line, which is equal to m. Okay, so if you actually come back to this equation where we had dy by dx is equal to 2x, then I told you that the first question we are asking is, what is the value of x right now? What is the value of x right now? And we said that we are standing at x is equal to 40, which means the slope is actually equal to 2 into 40, which is equal to 80. The slope is actually equal to 2 into 40, which is equal to 80. Okay. Now, if you actually carefully observe, when finding out the slope of the line, I did not ask the question as to what is the value of x right now. I did not ask the question of what is the value of x right now. Whereas over here, I actually had to ask what is the value of x right now, because the slope itself is dependent on x. Okay. If the value of x was equal to 20, then the slope would have been 2 into 20. If the value of x was 25, the slope would have been 2 into 25, which is equal to 50. So if you carefully observe, the slope itself is changing. Okay, over there dy by dx is equal to 3 was a constant, whereas over here dy by dx is equal to 2x, and this slope is going to change with the value of x. This value of slope is going to change with the value of x, and it is going to change because if you see, let us say I want to calculate the slope at x is equal to 80. What I will be doing is I will be drawing a tangent at this point. Okay, and if you see, obviously the steepness of this tangent is less than the steepness of this tangent. The steepness of this line, let me just highlight it. The steepness of this line is less than the steepness of this line. This is much more steeper, right? This is a little flat, and the second one is much more steeper. The first one is less steep. The second one is much more steep, and obviously the slope over here is going to be 2 into 80, which is equal to 160. 2 into 80, which is equal to 160. Apologies. Yeah. Okay. So the slope itself is changing. Now the slope at 10 is going to be a completely flat one. And over here, it's going to be 2 into 10 is equal to 20. Now we at lower levels, the tangent that is being made is actually a little more flat. And that is why the slope is less. As and when you're riding above the curve, as you are riding above the curve, the tangent is becoming steeper and steeper. And it's becoming steeper because you are drawing a tangent along the curve. Okay, you're drawing a tangent at a point where you're actually right now standing. Okay, so we drew a tangent at x is equal to 40 because we were standing at x equal to 40. Then in another instance, if we were standing at x equal to 80, we were actually drawing a tangent at x is equal to 80, and the slope in that case was 160, which means it's so steep that when x changes by 1 unit, the value of y is going to change by 160 units. When x changes by 1 unit, the value of y is going to change by 160 units if x is equal to 80. If x is equal to 40, and if the value of x changes by from 40 to 41, then the value of y is going to change by 80 units. That is 2 into 40, 80 units. Okay, I'll just repeat myself once again. If we are standing at x is equal to 40 and we are finding the slope as 80, then what it means is when x changes from 40 to 41, the value of y will increase by 80 units. When x changes from 40 to 41, the value of y increases by 80 units. If x is equal to 80, and if the value of x changes from 80 to 81, then the value of y is going to increase by 160 units. The value of y is going to increase by 160 units. If the value of x is equal to 10, then when x changes from 10 to 11, when x increases from 10 to 11, the value of y is going to increase just by 20 units. Okay, so in case of a line, from wherever we were moving from, that is the reason I actually gave this example, whether we are moving from x equal to 1 to 2, or whether we are moving from x equal to 100 to 101, the change in y is always equal to 3. Whether we are moving from x is equal to 1 to 2 or 100 to 101, the change in y is always equal to 3, and that is what I meant by slope being constant. But in this case, when x changes from 20 to 21, the change in y is only 40 units. But when x changes from 80 to 81, the change in y is 160 units. And this is because the slope itself is changing with change in x. When x increases, if you see over here, when x increases, the slope is increasing. This line is that the tangent is actually becoming much more steeper, and therefore the change in y is going to be magnified. When at higher levels of x, y is going to change by higher levels. At lower levels of x, y is going to change only by 20 units. For instance, over here, when x was equal to 10, y was only changing by 20 units. But when x is equal to 80, y is actually changing by 160 units. Okay, that is what we are trying to say by the fact that dy by dx over here is not constant, but it is a function of x. The slope of the line and the slope of the curve is itself a function of x. So that is the reason in case of a curve, the first question we need to ask is, what is the value of x right now? Okay, what is the value of x right now? And we are going to measure the change in y based on the current value of x. Whereas for a straight line, we are not going to ask what is the current value of x. We are straight away going to take the coefficient of x, and that is going to be constant. Okay, that is going to be constant irrespective of whether x is equal to 1 or whether x is equal to 100. Bottom line is, the slope for a curve keeps changing based on change in x. The slope of the curve keeps changing based on change in x. At lower over here, in this case where y is equal to x square, at lower levels of x we had a less slope. At higher levels of x we had a higher slope. Okay, that is what I'm trying to say. All right. Now, this is going to be the last discussion for this lecture. Now, what I said was, if x is equal to 10, then m is equal to 2 into 10, which is equal to 20. Okay. And if x is equal to 80, m is equal to 2 into 80, which is equal to 160. Okay. Please remember the interpretation of m. What is the interpretation of m? If x increases by 1 unit, how much does the value of y actually increase by? If x increases by 1 unit, how much does the value of y increase by? Let me actually take some space. I'll just write it down a little more. Okay. Now, if you actually see, so now what we are trying to say is, if x is equal to 11, then the value of y is going to increase by 20 units. That is what we are trying to say. If m is equal to 2 into 10, then if m is equal to 20, then we are saying that the value of y will actually increase by 20 units. So when x increases from 10 to 11, we are saying that the value of y will increase by 20 units. Can we actually cross check? If x is equal to 10, then y square is equal to 100. Okay, and if x is equal to 11, y square is equal to 121. Okay, if you carefully observe, I said that y should actually increase by 20 units, but over here y has increased by 21 units. Y has increased by 21 units. Okay, and now same thing if we actually apply over here. If x is equal to 81, then I am saying that y should actually increase by 160 units. If x is equal to 81, then y should actually increase by 160 units. Okay, should we apply? Now, if x is equal to 80, then y is equal to x square. Oh, apologies, I wrote y square over here, guys. I meant this is y actually. Y is equal to x square of 100. Y is equal to x square of 121. Okay, y is equal to 80 square, which is 6,400. And if x is equal to 81, then y is equal to, let us see what 81 square is. I have it ready over here. 81 is 6,561. 6,561. Again over here, if you look, we said that y should increase by 160 units, but y has actually increased by 161 units. 161 units, okay? Which means that what slope is actually saying is an approximate change in y. What the slope is actually saying is an approximate change in y, and it is not an actual change in y. Okay, in case of a line, the slope was the perfect change in y. Okay, we didn't have a difference when we actually calculated the change in, we actually calculated that y has changed by 3 units when x changed by 1 unit. Okay, so in case of a line, the slope is giving you the exact change in y for a given change in x. But for all curves, the slope is going to be giving you a approximate change in y. Okay, over here the difference was 1 unit. It can be something else as well. In this illustration, it is a difference of 1 unit, but it can obviously be something else as well. Okay, the slope is always giving you an approximate change in y for a given change in x in case of a curve, whereas for a straight line, it's giving you the exact change in y for a given change in x. Okay, please remember again, the slope is giving you an approximate change in y. Okay, this is not this is not stating that y will exactly increase by 160 units. It's saying that y will approximately increase by 160 units. All right. So obviously now if I actually say if x is equal to 80, m is equal to 160, and then I say what is the value of y when x decreases by 1 unit. I want to calculate the value of y when x decreases by 1 unit, which means if x is equal to 79, then slope is saying that y should be decreasing by 160. Okay, if x decreases by 1 unit, y is supposed to decrease by 160. Let us see what is actually the value of y is when the x is equal to 79. So y is equal to 79 square, which will be 79 multiplied by 79, which is 6,241. It is 6,241. So if you actually see the decrease in y, is actually 159 units. Okay, slope said that the value of y will fall by 160, whereas the actual y actually fell down by 159 units. Okay, therefore slope is an approximate measure. Slope is an approximate measure, or m is an approximate measure. It is saying that if the value of x right now is 80, and if the value of x increases or decreases by 1 unit, then the value of y will approximately change by 160 units. Okay, it's not giving you the exact change, it's going to give you the approximate change in y. All right, so please remember that it's going to give you an approximate change in y. Now, before we go ahead, let's actually understand why is it actually giving an approximate change instead of an actual change. Okay, now let us say I'm drawing an equation, I'm drawing a curve. Okay, I hope this curve comes out perfectly. Okay, it has not, but I think I'm okay with it. Yeah. Okay, let us say this is the curve. Okay, what we are actually doing is we are drawing, let's say this is x is equal to 80. we are actually drawing a tangent at this line. We are drawing a tangent at this line, and we found out the slope of this tangent, and we called that as the slope of the curve. Okay, and we said that when x increases from 80 to 81, or when x decreases from 80 to 79, then the value of y should increase or decrease by 160 units respectively. Now, what the slope is actually doing is it is giving you a point on this line. It's giving you a point on this line, whereas the actual point is lying on the curve, which is higher. The actual point is lying on the curve, which is higher than the point on the line. Okay, for instance, when 80 moved to 81, what slope said was the value of x is going to be 6,560. Okay, the slope equation is saying that the value of y will be 6,400 plus 160, which is 6,560. Okay, this is what was said by the slope formula, whereas the actual point is lying above on the curve, and this is 6,561. Okay, so the formula for slope is actually giving you a point on this tangent, and the tangent is obviously going to touch the curve only over here. It's not touching the curve above. So line and tangent, line and curve actually have a space. They have a gap in between, which is not being captured by the formula of slope. Okay, therefore slope said that the value of y will be 6,560, whereas the actual point on the curve is lying above, which is 6,561, and that difference is 1 unit. Now similarly, when x decreases from 80 to 79, the slope formula is saying that the value of x over here, the slope formula is saying that the value of y is going to be this point, whereas the actual point is lying above. Therefore, the slope was saying that this is going to be 6,240, whereas the actual point was 6,241, which is actually lying above. Okay, the formula for slope is actually giving you the points on the tangent, whereas the actual point is actually lying on the curve, which is slightly above the tangent. Okay, obviously the tangent and curve are not going to converge each other. It's called as a tangent because it touches it only at one point. Okay, there is some gap between the tangent and the curve where at x is equal to 79 and at x equal to 81, and therefore the slope is giving you an approximate change in y. It's giving you an approximate change in y, whereas the actual y is lying above the line. The actual y is lying above the tangent. Okay, this is what I wanted to discuss. And then finally, the last thing, and then I'll leave you guys for this video. Now, I said that the slope is giving you an approximate change in y. Now, what do I have to do to find out the exact change in y? I am not okay with approximation. I want the exact change in y. Then what am I supposed to do? There is something called as Taylor's theorem. There's something called as Taylor's theorem, which says that, it says that change in y is going to be change in x into dy by dx. This is what we were doing right now. When x changed by 1 unit, we actually saw what the derivative is, and we calculated the change in y as 160. Okay, it is saying that change in y is not just 160. It's going to have another term, which is half into change in x the whole square into second derivative of y. Okay, that is why I was calling this as first differentiation. Now we also have to do the second differentiation. Okay, what we were actually doing until now is just this portion. Okay, we were saying that change in y is going to be change in x. We assume that change in x is equal to 1. Okay, so 1 into dy by dx, which is nothing but 2x. So we were always trying to say that change in y is equal to 2x. Okay, but this is an approximate change. It has a second term also, which is 1 by 2 into change in x the whole square into the second differentiation of y. Now, obviously, I'm not telling you how this was derived. Okay, let's take this as a formula and let's go ahead. Okay, now if I actually say, let's take the example of x increasing from 80 to 81. Let's take the example of x increasing from 80 to 81. Okay, therefore, change in y is equal to change in x. Change in x in our case is 1 into dy by dx. dy by dx was nothing but 2x, and 2x is nothing but 2 into 80, because the current value of x is 80, plus half into change in x square. What is the change in x square? Which is 1 in 1 whole square. Okay, into d square y by dx. Okay, the second differentiation is going to be dy by dx is equal to 2x. D square by dx is going to be nothing but again d by dx of 2x, which is equal to 2. D by dx of 2x, which is equal to 2. Okay, therefore the second differentiation of y is actually equal to 2. And if you actually see half into change in x the whole square, which is change in x we have assumed to be 1 because we are moving from 80 to 81. Okay, multiplied by d square y by dx, which is equal to 2. Okay, so if you actually see 1, this is 160 plus 2 get cancelled, and we have 160 plus 1, which is equal to 161. Okay, therefore the exact change in y, is going to be change in x multiplied by dy by dx plus half into change in x the whole square plus d square y by dx square dx. This is this dx square. Yeah, I think this is supposed to be dx square. Okay, so this is going to be d square y by dx square, which is the second differentiation of this is also going to be d square y by dx. Okay, this is the second differentiation of y with respect to the independent variable. Okay, change in y is equal to change in x into dy by dx plus 1 by 2 into change in x the whole square into d square y by dx square. Okay, d square y by dx square is nothing but the second differentiation. Okay, now very quickly, for instance, let's hypothetically just cross check. Let us say the value of x is equal to 100 and I am increasing x not by 1 unit this time. Let us say I'm increasing it from 100 to 109. I've taken some random number 100 to 109. Okay, now let us see how much should be the change in y. Let's see how much should be the change in y. Now if we apply the formula, okay, firstly let's calculate the slope. The slope is going to be 2 into 100, which is equal to 200. Okay, the slope is going to be dy by dx. Okay, we calculated dy by dx as 2x, and therefore dy by dx is equal to slope is equal to 200. All right, so the meaning of this 200 is when x increases by 1 unit, the value of y increases by 200 units. When x decreases by 1 unit, the value of y approximately, I'm sorry, I should have used the word approximately. When x increases by 1 unit, the value of y increases approximately by 200 units. When the value of y decreases by, when the value of x decreases by 1 unit, the value of y approximately decreases by 200 units. Now here x has actually increased by 9 units. Okay, x has increased by 9 units, which means y is going to approximately increase by 200 into 9, which is 1800. Okay, y is going to approximately increase by 1800 units. This is not the actual one, this is the approximate. Okay, now if you actually see y is equal to x square is equal to 100 square is 10,000, and over here y equal to 109 square. Let me just quickly calculate. It is 11,881. Is it 11,881? Yeah. Okay. Now, if you actually carefully look at this, y has changed by 1,881 units. Okay. But whereas the formula for slope said that it's approximately going to change by 1,800 units, over here it has increased by 1,881 units. Okay. Therefore, slope is giving you an approximate change. Now, is there an alternative way to actually find out this 1881? Obviously, there is. We saw the formula, right? Change in y is equal to change in x multiplied by dy by dx plus half into change in x the whole square multiplied by d square y by dx square. Okay. This is nothing but what we have actually calculated as 1800 units, guys, because change in x is nothing but 9. It's positive 9, and dy by dx is nothing but 2x, which is 2 into 80, 2 into 100. Sorry, my bad. Okay, and this is going to be 1800. Obviously, that is what we actually just calculated. This is going to be 1800, but then we have half into change in x the whole square. X has changed by 9, so we have 9 square into d square y by dx square, and d square y by dx square, we saw that it is equal to 2. Okay, we saw that it's actually equal to 2. We calculated it somewhere. D square y by dx square, which is the second differentiation of y, is nothing but equal to 2. Okay, and now if we go ahead to solve it, we have 1800 units plus half into 81 into half again, These two get cancelled and we are going to get 1881 units. Okay. Now, basically, if I straight away apply this formula, I can get the change in y for a given change in x. X has changed by 9 units. How much will the value of y actually change by? And it is saying that value of y is going to change by 1881 units. And therefore, the revised value of y is going to be 10,000 plus 1881, which is 11,881. Okay, the revised value of y, let me maybe write it down. Revised y, or when x is equal to 109, is equal to current value of y, plus change in y, which is calculated above. Okay, current y is nothing but 10,000 plus change in y is nothing but 1881 units, which is equal to 11,881, and this exactly matches with the actual answer. Okay, or let me just forget it, let me not link it. This exactly will match with the actual answer of y is equal to 109 square, which is equal to 11,881. Okay, therefore, if I do not want to re-put the formula of y equal to x square, what I can actually do is I can calculate the current value of y, okay, the current value of y plus change in y, where the change in y is being measured using this formula. Okay, now the only thing is it is exactly matching over here because we took a equation which has a degree of 2. We took an equation which has degree of 2 because our equation was y equal to x square. Our equation was y equal to x square, and therefore the second differentiation d square y by dx square actually turned out to be a constant. Okay, the second differentiation of d square y by dx square turned out to be a constant, whereas if we would have had y equal to x power 3, then the second differentiation would have also been a variable. The second differentiation would have also been a variable. It would have also been a function of x. The third differentiation would have been a constant. Okay, over here the second differentiation was constant, but if we would have worked with a higher degree equation, the third differentiation will be a constant, and therefore the first two terms will still be an approximate change, but it will be a better approximation. Okay, you will then have a third term also, which we will not go into, which will not definitely go into the third term. But technically, this first plus second term is also then going to be just an approximate number. It will be an approximate change in value of y for a given change in x, because we have a third degree equation. Over here, we didn't have the third term because we were working with a second degree equation. Okay. Now you would have actually understood, probably, maybe if you would have given it a thought, the meaning of volatility was when YTM changes by 1%, how much does the price change by? When YTM changes by 1%, how much does the price change by? Okay, and that is nothing but price is a dependent variable, YTM or discount rate is the independent variable. Price is the dependent variable, like y, like how we had y over here. Price is the dependent variable and x is nothing but YTM, which is the independent variable. And that answer, duration or volatility, is going to be given by the slope of the curve, okay, which we will discuss and elaborate in the next video. Okay, over here, I think I have tried communicating, although it was basic mathematics of 11th, which you should have remembered, but I understand that a lot of you might, have not been, in touch with mathematics for a long time. So even if you have not understood, I think it's fine. You don't need this base necessarily for understanding duration and volatility, but it improves the understanding. Okay, that's it for this session, guys. Thank you so much. Meet you in the next class. Bye.